Welcome to our last class. I have trouble thinking how this term went by so fast. It always seems like that. So this is week 10, Thursday. If anyone in class needs a review day, let me know. We can schedule things over the weekend. We can schedule things next week. There's no more already scheduled things, but that doesn't mean I can't see you in finals week sometime when it fits your schedule. And if you give me notice, like tell me on Friday you want to do something on Monday or Tuesday, then I can send an email out to all the classmates and maybe help more people at once. Anyway, we have a couple of things today. There were 2 questions about the measurement, 10 questions that somebody wanted done. And then last time we were looking at a specific version of the practice final, just so we all had the same numbers to look at. And we got a tremendous amount done, but we didn't finish all of it. So I am expecting that after the questions that people had me put on the Jamboard already, then we will just sort of pick up where we left off and I'll be looking at the same one there. If you're wondering where this is, then when you go to our class and go to the syllabus and go down to week 10, then right by the Jamboard and the recordings, there's links to this test, this particular set of problems and the particular set of answers. If there's just a link that says practice finals, then that's going to open the normal page, which changes every time you load it. So good practice, but not the best thing to talk about if we all had a different version in front of us. And a reminder for how the final works, in case you were not paying attention last time, that these, when you load them, you have an answer key. So that's why it's a practice final. When you're ready for the real one, whether it's today or next week, then just let me know and I will print out a PDF version that has the answers and I will keep that. And then I will close the answer key and print it again and send that copy to you without the answers. So you would do that, send it back to me, send me photos of your papers, your scratch work, and then I will grade it. And then we'll meet and talk in Zoom and have a kind of in-person follow-up to the written one. So that's what your final is like. And if you get it done early before the end of finals week, then that means you can try more than one if you need to. So once again, this is today, Thursday. You can take a final anytime you want, but the last time you can turn one in is the end of the day on Friday, because ABSE office requires me to turn in grades at the end of finals week. So anything you turn in kind of after midnight on Friday is too late. But whether during finals week you take 1 final or 3, it doesn't matter. It's fast for me to grade. Do practice tests. Almost no one ever takes 3 because you know from the practice test if you're ready or not. But if you need to take more than 1, that's okay. But just that's a good reason to start earlier in the week so you have time to do another one if you actually were not ready enough for the practice tests. Okay, so back to this then. Yeah. So how large a circle can fit in a rectangle with a base of 12 feet and height of 5 feet? So I'm going to draw a circle. And I'm going to draw a rectangle. We want these to be, whoops, I have to move that one to the top. Something like that. So this is 12, and that is 5. In your picture, you might have done something a little different. You could have put your circle in the middle, You could have taken everything and turned it sideways a bit so the rectangle goes up and down, taller than it is sideways, but you'd have some picture like this. Okay, what's the area of a circle?
Pi times radius times radius.
Yeah. So now we know what we need. We need to somehow get the radius. Normally, I draw the radius kind of off to the right just by tradition. In this case, where's the easiest place to draw a radius to see how big it is?
The top.
Yeah, pick one of either up or down. And then you can say, now I can see things. How big is that blue line?
Is it 2.5?
It is. And how did you get that?
Half of the 5.
Yeah. So this side here was 5 feet. I should be good and label it feet, right? So half of that is 2.5 feet. Okay, now we got it. Now we just plug things in. So pi times 2.5 times 2.5. Pi is going to mean we're rounding. So pi times 2.5 times 2.5 gives me about 19.6. And we have this general rule of put as many decimal places as they give you. So none of them whole numbers, or maybe one more. You can have some accuracy when you chop things up into smaller pieces, but in general, you don't get 100 times more accuracy. We're just not that good at measuring things with rulers. Oops, and I labeled it wrong. What should I label this as?
Square feet.
Square feet. Questions about number 8?
No, that makes more sense. Thank you.
Was it just getting the picture, or was there something else that had been?
I think just seeing the circle in the rectangle was just more confusing to me.
Oh, okay. I unfortunately never had a good time this term to take a GED myself. ABSC offered, we'll give you a voucher code if you ever have time to do a proctored, real GED test. I have no idea how much this style of problem happens. I know they happen in other standardized tests where you have to draw the picture yourself. Once you get the picture, it's not that bad. So I am sort of being annoying with this homework to say, it's not a test, I'll be annoying. Can you draw your own pictures?
The pictures helped me. I just couldn't remember where to start from the circle.
Okay, so here we have square. Make this look a little bit more like a square. It's cut in half. And the rectangle that we get has a perimeter of 30. So if we go all the way around here, and that's a perimeter of 30. And then we're asked to find the area of the original square, both parts.
Would each side be 10?
Would each side be 10? Let's try it out and see. So you're thinking that this is 10. And this one is 10. And if this whole thing is 10, then since it's cut in half, that's 5 and 5. And that means this little bit is also 5 and 5, and that's also 10. Everyone with me so far?
Yeah.
So
Yeah.
10, 5, 10, 5. Yes, that is 30. So that is indeed true. How did you get that?
I found each side of the top rectangle to make up 30, and it was 10.
Some people do this by guess and check. They just plug in different numbers. They find out that if they make this 15, it's too big. If they make it 8, it's too small, and so on. If you wanted to, you could do fancy stuff with algebra. Have this plus half of it, plus this, plus half of it. So the two half of it's come together and make a whole one of it. So you get 3 of them is 30. And if 3 somethings is 30, divide both sides by 3 and you get 1 of them is 10. Either is fine. You can think with the algebra, you can do guess and check. It doesn't take too long either way. Okay, so we got that the original side is 10 and the rest is easy. It's again square feet. Wrong. Okay, that was the only 2 people had sent me ahead of time. Are there other questions people want from homework? And if not, we'll just keep going where we were last time.
I'm good.
Me too.
Okay, I'm going to pretend I don't know and say, oh, remember, look at the syllabus. How far did we get in the week 10 foldout last time? Just to kind of point out to people watching this, you can go to the Jamboard. So it looks like we got to 27. So we're on 28. Say back to okay, does anyone need me to put the link here in chat right now, just so that while you're in Zoom, you can look at it in another window easy?
Yes, please.
There you go. Okay. So a car drives 23 miles on 9.3 gallons of gasoline. At this rate, how many gallons are used on a 227-mile trip? So just sort of a heads up before we go into this. So far in the practice test, things sort of went in the order that we saw them in class. But after we get to 26, that one that's a math 25 level D problem, probably a good one to skip, but show off if you really want. 25 is sort of the similar thing. It's a little bit too hard for level C, but you can do it if you want. That's one reason you're allowed to skip 4 of them. 5 of them? 5 of them. Once we get past those 2 sort of extra hard ones, then everything gets shuffled. So these problems here, part of what makes them interesting is it's not quite obvious that we're going in order from week 1 to week 10. Can you figure out which topic this is about and do the problem the efficient way? Okay, so how do we start this one? What kind of problem is this?
Would you do 23 miles over 9.3 gallons?
Yeah, some people do this with a unit rate. If that's you, great. We've done the same kind of problem a few times, including Tuesday, where you can find the unit rate first and then multiply by 227. Most people want to do this as a proportion because they love cross multiplying. So our first situation is comparing this many miles to this many gallons. And then there's another equivalent situation, something proportional. And we know miles has to stay on top, gallons has to stay on bottom. Then we keep reading. At this rate, how many gallons, that must be what I don't know, are used by a 227-mile trip? Everyone okay with getting from the word problem to a proportion?
Yeah.
Yeah.
Then I'll pick the diagonal that has y and put y first, because that's how I like to do these. Now we had a stylistic thing. Some people like to put a line that's y times 23 equals, and then one number, what is 9.3 times 227. Other people think that's too much writing, and they go right to the divided by 23 on each side step. Which do you want to do?
Divide on each side.
Divide on each side. Oh, okay. So we have 9.3 times 227 divided by 23. Oops. I'm getting about 91.8. Before we leave this, we should look at it and say, does that seem reasonable? Remember, we talked about scaling. Going from 23 to 227 is almost times 10. Right? 230 would be times 10. We're pretty close. Is this number also about times 10?
Yeah.
Yeah, 9.3 to 91.8. It's 9-ish to 90-ish. That's about times 10 also. So it looks like it's about times 10, scaling both ways. So that gives me some confidence that I didn't hit something funny on the calculator, make a careless mistake. This seems like a good answer. Other questions on this one?
I'm good.
Does anyone want me to do it the unit rate way, where you start with 23 divided by?
Sure.
Okay. Oops. So the unit rate way, I would say that I'm going to do 23, no, other way, 9.3 gallons divided by 23 miles is, oops, time divided by about 0.404. I'm in the middle, so I'm going to not round much, 4043. So that's gallons per mile. And what I want is to arrange the order of division so that the number or the label after per matches up with the one that I haven't used yet. Then when I finish up, I'll get the same answer. You could also do this, and I'm going to do it another way before asking for questions on purpose with the unit analysis. So something they gave me in a fraction, this many gallons per mile, and I am multiplying it by the 227 miles. Actually, you're used to, I'm doing this wrong. 1 moment. I'm sorry. The way I have done this before, I should be consistent. So I'm starting with one thing, the 227 miles. It's not a fraction, so I put it over 1. And then I'm going to have to multiply it by something to get rid of the miles. And that puts gallons on the top like I want. Gallons is the only label left, and I will get the same thing, that 91.8. So if you are doing it with the unit rate method, you want per mile, so you can multiply it by miles and have them cancel out. It's the same thing as this many miles and this much per mile. Okay, but for almost everyone, they like the proportion method. You don't have to remember which one to divide by first or second. You don't have to remember like I did, should I put the gallons on top or the miles on top, or make this the first fraction or that the first fraction. So that's just flows better. Okay, questions on 28, any of those ways?
I'm
I'm
good.
good.
Okay, let me update attendance. Someone joined us. Welcome, welcome. Okay, 29. This one we've done other versions of with different numbers at least twice. We're going to get a little more tricky than the last time. Is this a good one to do again?
Yeah.
Okay, so we have two situations. We have three numbers and they're asking for another number. So that looks an awful lot like a proportion to me. Which two numbers are the first situation?
Is it 230 over 851?
There's two reasons to not do that. You could, but that's not having one situation on the right and one on the left.
Over
So
10
if you
instructors.
try that, you'll notice students is the same top and bottom, and that's usually confusing. So before they grew, it was 230 and 10. Randomly generated very small columns. And after they grow, it's 851 students. Students started on the top, so I have to put it on the top again. And instructors came on, stays on the bottom. Like instructions. Okay. Everyone with me so far?
Yeah.
Yeah.
Also going to remember in this one, they're tricking me or trying to. I'm finding how many instructors they have total in the new setup. But that's not what they're asking. They're only asking how many more do they have to hire. So I will have a concluding extra step after I've done this. Okay, I do my cross multiplying. So y times 230 is 10 times 851. And there will be a divided by 230 on both sides to get y by itself. And what is that? 10 times 851 divided by 230 gives me 37. Okay, so what's my last step?
Would you subtract?
You do. So take away the 10 they already have, and 27 more to hire. As before, if you really wanted to, you could do this as a unit rate thing, find the teacher to student ratio and work from there. You could do this with unit analysis, but I won't do those because most people like this, especially once the extra step comes in at the end. But if you did it the other way and got the same answer, great, more power to you. Questions on 29?
I'm good.
I would actually do it one of the other ways if someone really wants to.
Sure.
Sure. Which one? The unit analysis or the unit rate?
Unit rate.
Unit rate. Okay, so let me grab that. So the unit rate way. Again, if you're a proportion person, you can ignore this. Just think of happy thoughts for a moment. Okay, so the you want students per instructor. So the one that goes with the per instructor is the one that goes, whoops, with the, oh, I'm saying it wrong. I want instructors per students. So that the one that comes after the per goes with the new thing, which is the more greater number of students. So, yeah. Okay, so I phrased the thing we know. Initially, the instructors per student. So the per something matches with the new situations number. So then we write the 10 divided by the 230, because that's the original instructors and the original students. And we get whatever that is. .04348. Then I can take that unit rate and multiply it by the new number of students. And we'd get 37 instructors, just like before. And again, if it helps you to think like unit analysis, this is students over 1, so the students cancel out, and all that's left is instructors like we want. And then part 2 is again the 37 minus 10. Okay, now that I got things set up the right way, I'm happy with that slide.
Yeah.
Okay, 30 looks quick. How do we do this one?
I started by writing the arrows and then putting what they equal to.
Okay, so we translate everything. Numbers stay numbers. Is becomes equals. Percentages, we want to change into a decimal. That's what our calculator's like. Of becomes multiply, and what becomes a letter. So something is stuck onto y with times 0.1. How do I get rid of that?
Divide to both sides.
Divide both sides by that 0.1. That will get me the y by itself, because times divide undoes itself. What was the shortcut? I normally would want to do a calculator here, but I don't need to. I know a shortcut for divided by 0.1.
Would it be one scoot to the right?
It is. So if you had to use your calculator, no problem. But, oops, my box is full. If you happen to remember that, you could save a moment. We could also do this problem with the proportion method. Anyone want me to do that?
Yeah.
So with the proportion method, Then we had the percent, the number 100, and that was part over whole as a percent. And on the other side, we had the something that comes after the word of, and whatever number is left over and we haven't used it yet. And that turns into the part over whole as things we've counted. So in this case, that's always 100. The 10% is just a 10. We don't do ripple-off in the proportion method because we already have an over 100 right here to pay for that percent sign. Okay, of what? So the thing that comes after of is the thing I don't know. And what number have I not used yet? 227, or I'm sorry, 22.7. Then we'll do the proportion again. And get the same answer. Okay, questions about this slide?
I'm good.
$31 is terribly tricky. This is a kind of reward for showing up to class or watching the video. I want to do a percent sentence and say something is so much percent of something else, just like the previous problem. But this paragraph doesn't give me a percent and a counting number that match up. I'll draw a picture to explain. So we have some nice shiny red car, and 25% of it, so that's a quarter, goes away. What we want is how much of the car's value is left over and remains. And that slice of the pie is worth 21,300. Everyone with me so far?
Yeah.
We don't know the dollar value of how much depreciation happens. And at least initially, we don't know a percent value for how much is still there. One of those two things we can figure out. Which one can we find?
Sorry, what was the question again?
Okay, there's two numbers we don't have, a dollar value for that pie slice or a percent value for the green pie slice. And only one of those we can find. Which one is it?
The percent of the green?
It is. So I know this whole pie must be some dollar amount, but I don't know what that is. I also know that that whole pie is 100%. That I do know. So that means if I take that 100% and take away the 25% from the depreciation, 5 looks funny. Oh, that still looks funny. Then I have 75% is left over for the green slice. Does that make sense to everybody?
Yeah.
I would love it if I could do a subtraction problem with dollar amounts. What was the whole dollar amount? Take away this amount and get that. Or take the whole dollar amount, take away this amount and get that. But I don't have a whole dollar amount. But I know that the whole thing has to be 100%. Okay, well now I can start. I have 3 things. I know 2 of them. I'm looking for 1 of them. And they're the same slice of the pie. I can't fill out my percent sentence with numbers from 2 different pie slices. Okay, so the 75 is the percent. Does the 21,300 go in this spot or that spot?
Would it be the first spot?
It is. And how did you know that?
Well, I just kind of read it out in my head, and it didn't make sense if it was 75% of the 21,300.
Yeah, you could think about it that if we had 75% of 21, that would be 3/4 of this pie slice. That would be that I took this pie slice here, chopped it into 4 pieces, and shaded in 3 of them. That's not what I'm doing. Other people, it will make sense in their mind to say that this one, we keep saying, is the part, the change, the new, this is the whole, the original, the baseline for comparison. So then we can say, this is the part of the whole pie, and we are looking for the whole pie, the whole. And the rest isn't bad. Now we're to this kind of problem. But we had 2 tricky setup steps. One, realizing that we needed to get to a 75%, and then also which blank do we put that one in? So I'll stop right now. Questions about anything so far before we finish this up?
I'm good.
If you were to translate, numbers stay numbers, is becomes equals, we'll riplop, of becomes multiply, get y by itself. And whatever that is, 21,300 divided by 0.75, 28,400. Does that seem like a reasonable price for the whole pie?
Yeah.
Yeah.
Yeah. So if you want to feel smart, ask this problem to friends and family members. It's very rare to find someone that can get this right. Our instinct is to take these 2 numbers and multiply them and then subtract things away. And that actually gives you the wrong answer. Or take these 2 and multiply them and add that back to this. And that gives you the wrong answer. You can't do anything with the 25 because it's the wrong pie slice. You have to get to the 75 first. Okay. We have snail problems to confuse you. This one, I will give you a hint. We will need to know that 1 mile is 5,280 feet. We also need to know that there's 3 feet in a yard. Okay. Should I warm you up to this one, or do you want to jump right in?
I'm good with either way.
Warm us up.
Warm us up? Okay, if I was to say, what percent of a mile is blank feet, how would you do that? If I put like 5,000 in the blank, how would we do that problem? A hint for this is use what we know. If I say, what percentage of 5,280 feet is 5,000 feet? Does that make it easier?
Yeah. Would it be y times?
You're jumping ahead. So we started with some sort of fill in the blank things for percent sentences. So let's write that out. It helps to have it on paper.
Would we do unit analysis?
No, because there's a percent, and that's not what those tend to do. So what goes in my blanks?
So 5,000 is y
What percent?
of 5,280.
Does that make sense? Part is what percent of whole?
Yeah.
And then yes, you could translate, you could proportion, whatever works for you.
You missed a 0 on the
Oh,
5,000.
I missed a 0. There we go. So get y by itself. And I get about 94.7. Go right into percent. Okay, does that make sense? We're almost to a mile, but not quite with 5,000.
Yeah.
Yeah.
Yeah, okay, so that's your warm-up problem. Somebody is doing the same thing, but trying to make it tricky. So I will take the same blue thing that we needed before, but write it a little lower. And tell me how to eventually get there.
Would what go in the first line?
It's asking me for what percentage. So that's making me think that this has to be the what.
Would it be 5,280 is what percent of 840?
840. I want the percentage of a mile, just like here it was of a mile. So the mile is the whole amount, the baseline for comparison.
Would it be 840 is what percent of 5,280?
Almost. And I'm not going to write it as a mile. I'm going to write it as 5,280 feet, right? Just like we did in this one. I can't put 840 here. Why not?
Would it be 2,520?
How did you get that?
I did 840 times 3 because 1 yard is 3 feet.
So 840 times 3 is indeed whatever you said.
2,520.
So it's similar to what we did with the car. I need to compare things that are part of the same situation. So I need feet here and feet here.
Okay.
So that's why this was tricky compared to the warm-up, that here we only had to take one thing and make it into feet. Whereas here we had to take two things and bring them into something in common. How about that 31 days? What was that all about?
Is it just trying to trick you?
It is. It's only there to trick you. Ignore it. Cross it out. It doesn't matter how long it takes. We're just wondering what percentage of a mile a distance is. Okay, anyway, then we translate 2,520 is becomes equals. What becomes y? Of is multiplied 5,280. Again, get y by itself. We'll have to do some rip flop, but I'm running out of room. So 2520 divided by 5,280 gives me about 48%. Everyone okay with that one?
Yeah.
Yeah.
So this is a lot like something the GED will probably ask eventually. It likes this kind of mean thing where let's put in some information that's just a distraction. And we're going to give you something in yards and something in miles and ask you to compare them. And you need to be awake. Make sure you don't skip your food and coffee or whatever. I'd be alert and say, I need things to all be in the same if I'm comparing them. I can't compare apples and oranges, so let's make everything feet, because that's what I know how to do. Also, your notes should be your notes, not my notes. So don't just take this and hit print and use it on your final, but you can certainly recopy this. And as I recommended Tuesday, there's no limit on the amount of notes you have, but I would strongly advise you to prepare a quote cheat sheet, end of quote. Pretend that you had a 1 page or both sides of a page restriction on what you were allowed to use on the actual final. And as you're studying, just take the most important things, whether they're example problems or notes or whatever, and put them on that page. Just it'll make things so much easier on the test to not have to flip through pages and pages and pages of notes. And it will help your studying to know what you have down pat and what you still need to study. So if you want to copy these things from the Jamboard into your notes, you are welcome to do that. Okay, speaking of notes, how do you get from Celsius into Fahrenheit? If you don't have that memorized, then you could look it up. It's not here, it's in science, right? No, it is here, I just didn't see it. Okay, which one do we want? We have this one. We have that one.
The second one.
Second,
Oh, now
I'm hearing both.
I've said the second one because it's the second one you put on, but in order, the first one.
In order, I want to go from Celsius into Fahrenheit.
Oh, then yeah, the second.
Second.
That is this one. I want to put in something in the middle and have it spit out my answer on the other side. And actually, before we do that, I'm going to repaste them because I don't like that dot. I mean, here the dot looks fine. You can tell it's an ordered or an unordered list. But if I was looking at the Jamboard, that dot would confuse me. What's that dot all about? There's no lists happening. Oh, I should put them back in the same order I did. Okay, so now so what is that? 1.8 times 40 plus 32 gives me 104. It's, what is that? Hot tub temperature. So that's not too bad. Remember to plug things into the middle of the equation so it spits it out in the letter by itself. And if you're using this one, remember to put the parentheses in. Either do it first on your calculator and hit equals and then keep going, or have a calculator that has parenthesis keys. If you skip the parentheses, it's not going to work right. Questions about that one?
I'm good.
I'm good.
Okay, 34 gives you random shapes. But at least it gives you the shapes, unlike earlier where we had to draw the shape ourselves. So the square has a side of 21. Actually, I'm going to put, this is a little vague. Let's put the 21 there. The parallelogram has a base of 13.5 and a height of 10.5. I'm going to make the whole square red so I can color code things in a moment. Okay, so for these puzzly problems, I like 3 steps. One that's just a description, my plan, one that has equations, and then finally plug in some numbers on the 3rd step. So what's my just general plan? The shaded area is what? Am I subtracting things? Am I adding things?
Is it length times width?
That's the next row. I don't want any formulas yet. I just want you to talk about shapes. What am I doing with my flat dough I've rolled out in cookie cutters and pasting things together and all the rest?
I didn't hear what you said, sorry.
What am I doing as my general plan? Just words about shapes and adding or subtracting or something like that. How am I getting to this shaded area that I want?
Would you do square subtracted from the parallelogram?
Starting with my square, and then I'm taking away the parallelogram. Everyone okay with my plan?
Yeah.
So the danger on a test isn't really that you do the math wrong, it's that you try and skip too much and do too much in your head, or you take a problem and try and make it harder than it is. So in this one, if I make my plan, then it's easier for me to say, now I know the formulas. This is length times width, and this one is base times height. And I can go from my shape to my area formula and not confuse myself. And then finally, I can plug things in. So maybe this is writing too much. You think I'm wasting space on my paper. You could do this without all 3 steps. But it's nice to be organized. Everyone with me with my setup?
Yeah.
Yeah.
So these are terms. I don't need parentheses. It already knows with order of operations, my calculator will multiply before I do any subtraction. So I can just put it right in. 21 times 21 minus 13.5 times 10.5. And if they didn't hit anything wrong, 299.25. And it's an area, so it's square units and feet. Okay, questions about that one?
I'm good.
Mhm. Okay, not everyone likes trying to write equations with just shapes in them, but I encourage you, if you don't have a different habit that works for you, try this. It keeps you organized. It lets you remember, I want this equation for that area shape, this equation for the area of that shape. Okay. This one, I need a picture. I'm going to try to draw a good picture so that I can add it to the test. See how well I do this. Okay, so an apartment building roof is shaped like two rectangles, a front and back. But these aren't really flat in space like that. Since it's a roof, I'm going to draw it where kind of looking at the front of the house. Does that make sense? So here's one of these rectangles. And there's another one we can't see because it's going kind of back away from us on the far side of the house. And there's two triangles. That's here. And then there's another triangle. Oops. But we can't see it either. So there's our other rectangle on the back. And here's the other triangle on the other side of the house. Does my picture make sense?
Yeah.
Okay, so the rectangles are 105 feet by 23 feet. And the triangles have a base of 22 feet and a height going up and down of 19. Okay, are we good so far?
Yeah.
Yeah.
So we have not just one of these, but there's 12 apartment buildings. I'm just going to highlight that for now. I'm sure I'll probably want the 12 somewhere. One container of moss powder will treat 600 square feet of the roof and costs $15. How many containers are needed? Round up at the end. And how much will they cost? Ah, now I'm starting to see what's happening. So I have this green number, 600 square feet of roof for one container. So what does that tell me I need to do with this roof?
Find the area.
Find the area. So one roof has a triangle on this side, a rectangle on the top, the rectangle, I know on the bottom, like away from you and towards you in my picture, right? And then the triangle on the other side. Everyone okay with that?
Yeah.
Yeah.
So that's a 0.5 times base times height plus a length times width. If you wanted to just double all of that, you could, or you could add it twice, whichever makes sense to your brain. Okay, now I'll plug things in. So the base was 22. And the height was 19. Not fit, I shouldn't jump over there. 105 and 23.
Apologize. Oh, you're.
Okay, ready for all of that?
Yeah.
So it's the 0.05 times 22 times 19. And to that, I'm adding whatever it was, 105 times 23. And then that I can just double to get the other two copies of the shape. Oops. Okay, 4,871.8. So that's each of the roofs. So now I know what to do with the 12. Tell me how to keep going. Do you need a hint or are you just distracted?
And
A hint. So one roof had this much area. We added all the shapes up. But
So
we
then
need,
multiply 6.
yeah, we have 12 different apartment buildings. So we have to do this times 12. So 58,461.6. So that's how many square feet I really need to put stuff on. Okay, I still have more things to do.
Do you divide next
Yes.
by 600?
So how many different containers do we need? So I'll take that divided by 600. We need 97, and it says to round up so we don't run out. So 98 containers. Everyone clear about why we're dividing?
Yeah.
Yeah.
We're so close to done. How much will they cost?
$15 each.
15. $1,470. Ta-da! And I hate to say it, but the GED also likes having at least one problem like this, where you just have lots of steps. Mixing up kinds of things of, are we doing geometry? Are we doing a division to find how many are needed? Are we putting some money in? So that's why this problem's on the test. Questions about all of it?
I'm good.
I'm good.
Okay. And a similar annoyance. Another GED-like problem with lots of steps. So let's draw the picture for this. A one-story ranch-style house has a central area. We have a right and left. Let's put this below. And where the rooms are 19 feet high. Not sure what I'm going to do with that yet, but I'll put it kind of close to that. A right wing, in which the rooms are 11 feet high. I might have to fix my shape. I'm just sort of putting things in. And a left wing, in which they're 15 feet high. Okay, now I get other things. The central area is 24 by 84. So 84 feet and 24 feet. The right wing has 5 rooms, each 15 by 16. So I kind of drew the wrong thing. I'm pretty sure they are not all in a line, but I'm just going to pretend they are. 1, 2, 3, 4, 5. So each one of those is 15 feet by 16 feet. And we have 5 of them. The left wing also has 5 rooms, but they're bigger, 19 by 18. Okay. Everyone okay with my picture?
Yeah.
I'm imagining that in real life, it's probably true that there's like some hallways and some of these rooms are over here and so on, but I don't care. Okay, the house needs to be fumigated. Oh, poor people. It requires a container that must be like bug gas, right, for every 5,000 cubic feet, and they cost that. How many containers are needed, round it up so we get enough fumigation, and how much will this all cost? And somebody is saying there are bathrooms, it's okay, we're ignoring them. Okay, now the height stuff makes sense. We talked about volume a little bit. If these rooms are not actually just flat, but have a height, excuse my lousy artwork, what was our formula for the volume of a box like that? I think we only did this one day. If you weren't here that day, that's okay. Do you need a reminder?
Yes.
Okay, so the reminder is think about the carpet and how big that is, and then sort of think like a skyscraper. We're making different 1 foot tall copies of the carpet to see how many cubes it takes to fill up this thing. So the carpet was just the length times width. And then we're saying how many of those are there. So that's the height. Does that ring a bell now?
Yeah, it does.
So we have 11 boxes. We have 5 boxes and 1 box and 5 box. So I'm out of room. I'm going to the new thing. So our house volume is 5 times the rooms on the left plus the big room in the middle plus the 5 in blue on the other side. Everyone okay with my plan? I'm sorry, it's on 2 different slides. I have these 5 rooms plus the big area in the middle, and then plus those 5 rooms. Each room is length times width times height. Okay, questions before I start plugging things in?
I don't have any.
Oh, okay. So that was 18, 19, and 15 was how tall those were. The big open area was 84 by 24 by 19, very big. And then the smaller rooms on the right were 15, 16, and 11. So 5 times 18 times 19 times 15, was it? Yes, so 25,650. $84, 24, 19. $38,304. Times 16 times 11, 13,200. And add those up. $77,154. So this isn't feet, nor is it square feet. This is now cubic feet. We're saying if we took tiny little cubes and tried to fill up this room, imagine like the foam blocks in the gym pit under the bars or something, then how many cubes would it take? Okay, we're not done, but now it's just like this one. So every 5,000, we need a new container. You knew that was division last time. So rounding up 15, round up to 16 containers. And each one costs what? 38 bucks. These are expensive. Oops. Okay, 608. Questions on that one?
No, thank you.
Thank you. So lots of steps, but hopefully it makes sense now that it's all laid out in beautiful color. Any questions again before I go on? Because that was a lot of stuff. Okay. This one is because we had patterns presented to us. So if we make a table, then we have N and Y, and let's draw it with shapes. Don't make this harder than it's supposed to be. So 1, 2, 3, 4. If I plug N equals 1 in, what do I get out? 6 times 1 plus 5.
11.
11. Yeah. If I plug in 2, what do I get out?
17.
If I plug in 3, what do I get?
23.
And 4.
29.
You don't have to notice this, but you might as well. What's my rule for how much it goes up each time?
Six.
Plus 6. Do you see why it's plus 6? Each time we make this bigger, we get another 6. We have 1 6s or 2 6s or 3 6s or 4 6s. So what I'm actually going to do then is, it goes on. I'm going to make this part be blue. And I'll make this part be green. So first I want to draw 11 shapes, and I'll just do circles because I'm lazy. So here's 6 circles, and then 5 more that I've added on. For my 17 shapes, I'm going to take my 6 circles and do them twice. They don't play nice together. Oh well. I'll have to actually draw. And then I can put my green ones back. Is that hopefully clear?
Are
that
you
I
missing a circle on the green?
Oh, I am. Thank you. Is that hopefully clear that we have 1 6 and 5? We have 2 6s and 5.
Yeah.
So then for the next one, I'll put another 6s and 5. And for the last row, more 6s. Now I have 4 6s and 5, like that. So something like that. You can draw whatever you want, but the goal of this problem is to show that you're understanding that this is making copies of 6, and this is just, there's always 5 stuck on at the end. Questions about that one?
I'm good.
That's kind of an annoying, what does the teacher want? But anyway. Then a last problem to show off with. This is officially level D, but you can do it great. I have 9 somethings, and that's 5 of them, and 8 more. I want an equation that's just something times W is a number. So what can I do so only one side has W's? Any ideas?
Can you subtract 5W?
I can't. So what starts with W? Watermelons. So we're saying that Emily has 9 watermelons, and that cost her as much as Sequoia's 5 watermelons plus $8. Something like that. Does that make sense as a story to go with this?
Yeah.
So if both of them eat 5 watermelons, then Sequoia ate all hers. All that she has left is the $8 that she didn't spend on watermelons. Emily had 9 watermelons and ate 5 of them, so she's down to 4 watermelons. And now this looks like what we like. Something times W is something else. So that we know well. Let's get W by itself. The opposite of times W is divided by, sorry, opposite of times 4 is divided by 4. So each watermelon is $2, except that we don't know it's actually watermelons or money. Does this work? We can try it. 18 is 10 plus 8. Sure, that works. So this part is level D math. This part is level C math. But most people like showing off and getting an extra point on the test. Again, you're allowed to skip 5 problems, so the fact that some of them are tricky is okay. You want me to do more like this?
Yeah.
Now I have to go to random problems. Okay. That one looks scary. It has the number 13 in it. So different place, different watermelons. Somebody has 13 watermelons. Someone else has 5. If you were to buy 5 and spend $64, that would be the same as 13 watermelons. So what was our first step?
Subtract 5W.
So both people eat 5 watermelons. This person only has the $64 they saved by not buying so many. This person had 13, they eat 5 of them. What's left is 8 times 1. Okay, times 8 is stuck on. So the opposite is divided by 8. These must be bigger watermelons. 8 times 8 is 64, right? They cost more than the other random ones.
They're in New York City.
Yeah, New York City watermelons, says my wife. Okay, that one had 5 and that one had 5. Let's do one more that doesn't have a 5 there, just to make sure you understand. Okay, what's my first step?
Subtract the 4W.
So again, watermelon feasting time. If you had 4 and ate 4, you don't have any left, just the $35 you didn't spend on watermelons. The person that spent all their money eats 4, there's 7 watermelons left. So how much was each? And there we go. Not quite a free point, but that's easier than a lot of the other things we just did, right? Okay, we've now done every problem. It's only 8 o'clock. Do you want to stop early? Do you want to schedule something happening on the weekend or next week? That's probably a very smart thing to do. Should I put something on the calendar?
So we won't have any classes next week?
No, if you want, we can. And that wouldn't surprise me if like 6 p.m. Tuesday fits everyone's schedule, because we've all set up our work schedule to have that work, right?
We
But
don't have Zoom at all next week.
don't have what?
We don't have a Zoom meeting at all next week.
There's none scheduled by default. Okay, this finals week classes are now done, but we can certainly meet. So I am at your disposal. We might want something before Tuesday, just if people get a test and get stuck and want, if you're doing practice tests and want help, then waiting until Tuesday is an awful lot of the time you have left. Should we put something 6 p.m. Tuesday?
Sure.
Sure. Okay. Let me get my calendar open. Okay. No, not that. Okay, now if I hit reload, there it is. Okay, what else? Nothing Friday, Saturday, Sunday, Monday?
I'm busy all this weekend.
I'm gonna try and start the final this weekend.
Okay,
If for some reason I get a bad score, then I can see if I can meet up after that.
okay, that makes sense to me. Then try it again. Okay, well, if you don't need something on the calendar right now, then just holler when you do. And again, the more advanced notice you give me, the more other people might attend and be efficient that way. Who's taking other finals next week?
I am.
Well, may those go well.
Thank you.
We, before the recording started, had somebody go through and get a lot more achievements checked off. If you want to do that, let me know. A good time to do that is just when you are doing the oral exam. After you turn in your written work and we talk about it, and as long as we're in Zoom together, let's go through and get all your achievements checked off. I can also tell you, you won't know this unless I share it, but there's a thing I do with how many achievements you do total. You can see it here. And how many color groups have 3 or more, and that would determine, and your final exam score. And those 3 things go together in a certain way to get your letter grade if this was Math 20 and you were graded. But I can certainly tell you, even though you're not graded in level C, what grade you would earn, just so you can brag to all your family, I would have gotten an A, or whatever, right? So we can go over that after your test and the oral exam also. I can say, great job, you got this many achievements, you got 3 or more in this many color groups, your final exam was this much. So here's the letter grade you would have gotten if I could give you a letter grade.
So when are we doing the oral exam?
Just kind of whenever it works based on your schedule. So most people do it the same day or the day after they turn things in, just because we're grown-ups with jobs and kids, and the day that we have enough time to do it tends to be the day we have enough time to talk about it. But it doesn't have to be. If you turn it in on Wednesday, then we can meet Friday or whatever. Just again, Friday midnight has to be when everything is done.
So we just make a meeting with you?
Yep.
Okay.
And if you don't make a suggestion when you email me the pictures of your scratch work, then I will when I reply and tell you how you did when I grade things, then I will add that and say, great job, you got this % on your final. By the way, suggest a day or time or a couple days and times, and I'll tell you which one works. And then you can reply and say, I can meet, Wednesday at 8 in the morning, or Wednesday at 9 at night, or Thursday at noon. And I'll say, well, the Wednesday 8 in the morning works for me, like that.
So it's just going over our test with you and meeting.
Yeah, again, there's 3 things. I can list them out. One is something you're proud of, which problem either was hard and you're happy you could do it, or relates to your future plans and career goals or something like that. A second thing is fixing careless errors. All of these problems have lots of steps, or most of them have lots of steps. And it just feels bad if you made a silly mistake in something that had so much stuff going on and then never got a chance to fix it. Right? So I will say, on this one, you knew what you were doing, but you had a number wrong in that row or something like that. And you can figure it out and fix it. And then find other mistakes. So either I will do problems wrong on purpose, or I will copy and paste them from the photos you send me, but there will be problems that, let me find an easier one. Somebody will do something wrong, like, what if we changed this one? So people added the 40 and the 32 first and did 1.8 times 72. Got 129.6. So I would show you a Jamboard with other people's mistakes on it, mine or a classmate's. And then your job would be to find where the mistake is. And you can say, well, that looks right. And that looks right. And then you could check it and say, oh, that's not 129.6. It's supposed to be 104. And I'd say, yay, you found it. And that's the hardest part, because it's harder to find where somebody messed up, because your brain wants to believe everything in front of you. And that does 2 things. One, it really lets you show off what you know. And 2, it's just to make sure for a graded class that no one is cheating, that this really is you doing your work and you didn't have your best friend or whatever do your written work. Since you're not being graded, then cheating really isn't a problem, because they're not going to take the GED for you. You have to learn it, right? But there we go. So that's the 3 things. And I guess number 4 was achievements. Make sure those are all done, that you know what grade it would be if you care, and so on. So nothing stressful. This is the only part that is you doing new math, and it is both hard and easier than you think it will be. Questions?
And then we just send you the pictures right through email with the PDF.
It doesn't have to be a PDF.
It can just be on paper.
Yeah, just take pictures of your paper and send them to me. And some people send them as a text. If it's easier to text them to me, then do that. You have my text phone number right there. Depending on your phone, for some people, it's much easier to text me photos than to get them in email. It's easier for me if you email them, but whatever works best for you.
So for when we're doing it on paper, can we just write the number to the problem, or do you want us to write out the question and then do the problem when we send it to you?
You don't have to copy the whole problem. No. Just write the number so I know what you're doing.
Okay.
So an example is let's see, documents. So here, for example, this isn't your class, but a student just took pictures of the thing. And she happened to make, or I made a PDF of it. She just sent me pictures, but you see I draw on it with my pen. I show her where there's small mistakes. I show her where she messed up big. The big ones we don't care about. The small mistakes she can fix when we meet. Like that. Make sense?
Yeah, thank you.
I tend to put everything together as a PDF just because it is easier for my archives to not have all these individual pictures floating around. But that is my job. If you just send me pictures, that is great. If your phone
Wait,
automatically makes PDFs.
Do we send you pictures of the practice final exam or of our work for the final exam?
The practice finals, you are grading yourself, right? At the bottom, you see your answers. So I like to know when you did them. And if you get 66% or more, then that's an achievement. But other than bragging, sending me a quick email saying, I did a practice final and I got 80% or whatever, then you don't have to let me know you've done them. Some students do just one, some students do 10 of them, whatever you need to be good at things. And again, don't necessarily sit down and try and do all 38 problems in one sitting. That's not how practice works. But once you've done enough problems, then I will print it out as a PDF without the answers and send that to you as your real one, number one. That makes sense?
So do we send you pictures of our work from that? I'm a little confused.
And that's the one you send me pictures. Yeah,
Okay.
Don't send me pictures of the work from your practice. Send me pictures of the work from the real one that you don't know the answers to, so I can grade it.
Okay.
And as I mentioned before, I don't know if I was recording at the time, don't waste a lot of time being stuck. If you're trying one and you can't get it in a few minutes, then send me an email. I'm stuck on number 16. Here is what my version of it said, because I won't know if I reload it, right? And then I can help you. Don't waste half an hour of your life trying to do one math problem. And we have now done all of these kinds of problems in the week 10 foldout. So Tuesday we had a bunch and we'll finish up today. Anything else?
I'm good.
So as of right now, the only meeting we have next week is on Tuesday at 6.
Yep.
Okay.
Some people will be all done. They'll have turned in their final and done great on it by then. And other people won't, and that's okay. We'll meet as much as we need to. If we're done, let's stop 5 minutes early. Have a great night. Have a great weekend if I don't see you again. But don't be a stranger. Ask for help if you need it, and I can help you by email, or we can just get together in Zoom for a few minutes or whatever.
Good night.
Good night.